Life on Mars? It's hard enough to identify fossilized microbes on Earth. How would we ever recognize them on Mars? On August 7, 1996, reporters, photographers and television camera operators surged into NASA headquarters in Washington, D.C. The crowd focused not on the row of seated scientists in NASA's auditorium but on a small, clear plastic box on the table in front of them. Inside the box was a velvet pillow, and nestled on it like a crown jewel was a rock from Mars. Scientists announced that they'd found signs of life inside the meteorite. NASA Administrator Daniel Goldin gleefully said it was an unbelievable day. He was more accurate than he knew. The rock, the researchers explained, had formed 4.5 billion years ago on Mars, where it remained until 16 million years ago, when it was launched into space, probably by the impact of an asteroid. The rock wandered the inner solar system until 13,000 years ago, when it fell to Antarctica. It sat on the ice near Allen Hills until 1984, when snowmobiling geologists scooped it up. Scientists headed by David McKay of the Johnson Space Center in Houston found that the rock, called ALH 84001, had a peculiar chemical makeup. It contained a combination of minerals and carbon compounds that on Earth are created by microbes. It also had crystals of magnetic iron oxide, called magnetite, which some bacteria produce. McKay presented to the crowd an electron microscope view of the rock showing chains of globules that bore a striking resemblance to chains that some bacteria form on Earth. "We believe that these are indeed microfossils from Mars," McKay said, adding that the evidence wasn't absolute proof of past Martian life but rather, pointers in that direction. Among the last to speak that day was J. William Schopf, a University of California at Los Angeles paleobiologist, who specializes in early Earth fossils. "I'll show you the oldest evidence of life on this planet," Schopf said to the audience, and displayed a slide of a 3.465 billion-year-old fossilized chain of microscopic globules that he had found in Australia. "These are demonstrably fossils," Schopf said, implying that NASA's Martian pictures were not. He closed by quoting the astronomer Carl Sagan, "Extraordinary claims require extraordinary evidence." Despite Schopf's note of skepticism, the NASA announcement was trumpeted worldwide. "Mars lived. Rock shows meteorite holds evidence of life on another world," said the New York Times. "Fossil from the red planet may prove that we are not alone," declared the Independent of London. Over the past 9 years, scientists have taken Sagan's words very much to heart. They've scrutinized the Martian meteorite, which is now on view at the Smithsonian's National Museum of Natural History. And today few believe that it harbored Martian microbes. The controversy has prompted scientists to ask how they can know whether some blob, crystal or chemical oddity is a sign of life, even on Earth. A debate has flared up over some of the oldest evidence for life on Earth, including the fossils that Schopf proudly displayed in 1996. Some scientists propose that for the first few 100 million years that life existed, it bore little resemblance to life as we know it today. NASA researchers are taking lessons from the debate about life on Earth to Mars. If all goes as planned, a new generation of rovers will arrive on Mars within the next decade. These missions will incorporate cutting-edge biotechnology designed to detect individual molecules made by Martian organisms, either living or long dead. The search for life on Mars has become more urgent thanks in part to probes by the 2 rovers now roaming Mars' surface and another spaceship that is orbiting the planet. In recent months, they've made a series of astonishing discoveries that, once again, tempt scientists to believe that Mars harbors life, or did so in the past. At a February conference in the Netherlands, an audience of Mars experts was surveyed about Martian life. Some 75% of the scientists said they thought life once existed there, and of them, 25% think that Mars harbors life today. The search for the fossil remains of primitive single-celled organisms like bacteria took off in 1953, when Stanley Tyler, an economic geologist at the University of Wisconsin, puzzled over some 2.1 billion-year-old rocks he gathered in Ontario, Canada. His glassy black rocks known as cherts were loaded with strange, microscopic filaments and hollow balls. Working with Harvard paleobotanist Elso Bargorn, Tyler proposed that the shapes were actually fossils, left behind by ancient lifeforms such as algae. Before Tyler and Bargorn's work, few fossils had been found that predated the Cambrian period, which began about 540 million years ago. Now the 2 scientists were positing that life was present much earlier in the 4.55 billion-year history of our planet. How much further back it went remained for later scientists to discover. In the next decades, paleontologists in Africa found 3-billion-year-old fossil traces of microscopic bacteria that had lived in massive marine reefs. Bacteria can also form what are called biofilms. Colonies that grow in thin layers over surfaces such as rocks and the ocean floor, and scientists have found solid evidence for biofilms dating back 3.2 billion years. But at the time of the NASA press conference, the oldest fossil claim belonged to UCLA's William Schopf, the man who spoke skeptically about NASA's finds at the same conference. During the 1960s, 70s and 80s, Schopf had become a leading expert on early lifeforms, discovering fossils around the world, including 3-billion-year-old fossilized bacteria in South Africa. Then, in 1987, he and some colleagues reported that they had found the 3.465 billion-year-old microscopic fossils at a site called Warrawoona in the Western Australia outback, the ones he would display at the NASA press conference. The bacteria in the fossils were so sophisticated, Schopf says, that they indicate life was flourishing at that time, and thus, life originated appreciably earlier than 3.5 billion years ago. Since then, scientists have developed other methods for detecting signs of early life on Earth. One involves measuring different isotopes, or atomic forms, of carbon. The ratio of the isotopes indicates that the carbon was once part of a living thing. A team of researchers reported that they had found life's signature in rocks from Greenland dating back 3.83 billion years. The signs of life in Australia and Greenland were remarkably old, especially considering that life probably could not have persisted on Earth for the planet's first few hundreds of millions of years. That's because asteroids were bombarding it, boiling the oceans and likely sterilizing the planet's surface before about 3.8 billion years ago. The fossil evidence suggested that life emerged soon after our world cooled down. As Schopf wrote in his book Cradle of Life, his 1987 discovery tells us that early evolution proceeded very far very fast. A quick start to life on Earth could mean that life could also emerge quickly on other worlds, either Earth-like planets circling other stars, or perhaps even other planets or moons in our own solar system. Of these, Mars has long looked the most promising. Sooner, in 2009, NASA will launch the Mars Science Laboratory rover. It's designed to inspect the surface of rocks for peculiar textures left by biofilms. The Mars lab may also look for amino acids, the building blocks of proteins, or other organic compounds. Finding such compounds wouldn't prove the existence of life on Mars, but it would bolster the case for it and spur NASA scientists to look more closely. Difficult as the Mars analyses will be, they're made even more complex by the threat of contamination. Mars has been visited by 9 spacecraft, from Mars, a Soviet probe that crashed into the planet in 1971, to NASA's Opportunity and Spirit. Any one of them might have carried hitchhiking Earth microbes. It might be that they crash-landed and liked it there. And then the wind could blow them all over the place, says Jan Toporski, a geologist at the University of Kiel, in Germany. And the same interplanetary game of bumper cars that hurtled a piece of Mars to Earth might have showered pieces of Earth on Mars. If one of those terrestrial rocks was contaminated with microbes, the organisms might have survived on Mars for a time, at least, and left traces in the geology there. Still, scientists are confident they can develop tools to distinguish between imported Earth microbes and Martian ones. Finding signs of life on Mars is by no means the only goal. If you find a habitable environment and don't find it inhabited, then that tells you something, says Steele. If there is no life, then why is there no life? The answer leads to more questions. The first would be what makes life abounding Earth so special. Did you learn something new about the Mars that you didn't know before? We hope you did. So, if you're interested in learning more amazing space news, make sure to subscribe to our YouTube channel and hit the bell icon to get notified by our new videos. Please like and share the video. Don't forget comment down your views on this. Thanks for watching till the end.